Good morning, my name is Kenneth Lee Williams, and I've been doing a little research on asthma, which is what I'm going to be teaching you a little bit about today. But first, I chose asthma because my mom over there, her twin sister, who's also my aunt, were both diagnosed with asthma because they were born prematurely and their lungs didn't have time to fully develop. So I thought I'd do asthma because it'd be interesting and I wanted to learn more about it. First, what is asthma? Asthma is a chronic inflammatory lung disease. That means that it happens often, all the time, and it just causes inflammation, causes parts of your body to swell and burn up. It's inheritable, which means that a parent with asthma can pass it on to its offspring, which luckily I didn't get it. It also increases its capability to target genes, which I'll talk a little bit more about later. It can cause symptoms such as narrowing of the airway, shortness of breath or trouble breathing, chest tightness, dry cough, wheezing. And the history of asthma dates back to ancient times before 2600 BC. It was only known as noisy breathing in ancient China. First, to understand how asthma affects cell communication, we have to understand cell communication itself. Cell communication is one of the body's most important functions as it allows cells to function properly and react to external stimuli appropriately. The first stage of the three stages of cell communication is reception. A ligand or a signaling molecule binds to a receptor protein on the outside of a target cell. Then comes transduction, when the ligand binds to the receptor protein and it sends a signal throughout the cell and amplifies it. And then finally, the response. The cell receives the signal and begins carrying out different tasks based on the signal received. It can go anywhere from cell growth, division, death, or even gene expression. Cells use two different kinds of signaling, local and long-distance signaling. Local distance signaling often happening within the same tissue, and long-distance signaling happening over the span of multiple tissues, sometimes even spanning across the entire organism. Asthma has aspects of both local and long-distance signaling since it mainly happens in the airways, but it can affect the whole organism. Asthma targets epithelial cells within the airways, which provide protection against external irritants, mainly allergens, such as pollen and all that. They also work together with TSLP, or thymic stromal lymphopoietin, IL-25 and IL-23, which are cytokines that act as key initiators of type 2 inflammation and immunity. These cytokines also serve as alarmins that alert the body of any damaged cells or tissues to help them get repaired. Here's just an example of a normal airway compared to an asthmatic airway. As you can see, the farther right it gets, the inflammation and mucus begins to build up, and the mucus finally forms a mucus plug, and it leaves barely any room for the airway to breathe and take in oxygen. So first, where the breakdowns occur, asthma's attack on cell communication begins in the JAK-STAT, IL-4, and IL-13 pathways, which are found in parts of the immune system surrounding the airways. There are the main pathways that induce type 2 inflammation, a common symptom of asthma. Since asthma is inheritable and therefore linked to genetics, it is also linked to the 9q section of the chromosome. More on that in a bit. The IL-4 and IL-13 pathways work together to promote airway inflammation, mucus production, and recruit inflammatory cells. The JAK-STAT pathway is also a major part of the breakdown where asthma occurs. The JAK-STAT pathway is critical for the Th2-mediated inflammation in asthma. It transmits signals from cytokines like IL-4 and IL-13, which drive key aspects of the disease, such as allergic inflammation, mucus production, and airway hyperresponsiveness. Hyperresponsiveness is a big deal with asthma as it causes cells to overproduce a lot, especially mucus, since it's the main thing that clogs up airways. A group of cytokines known as Janus kinases, or JAKs, activate STAT through phosphorylation or the addition of a phosphate group to the molecule. Afterwards, it goes downstream and it starts making genes do whatever it needs to do. After phosphorylation, the new STAT molecule will go downstream to trigger a signal that will allow the cell to transcribe genes and contribute to asthmatic responses. So here's just an example of IL-4, IL-13, and JAK-STAT. As you can see, IL-4 and IL-13 both send proteins down, and JAK comes down from the wall and phosphorylates, turns into STAT. STAT goes down to the genes, and the genes transcribe and carry out their tasks. Asthma was also found to be linked directly to chromosome 9q, or the deleted section of chromosome 9 that is found to be directly linked to asthma, being more strongly connected through those of Mexican origin. Although no cure for asthma has been discovered, multiple methods of treating and managing asthma symptoms have been discovered and widely used by the public. More commonly known, inhalers, which I have a few of on the board here. They are also known as corticosteroids or inhaled corticosteroids. They expand the airway and send medication straight to the lungs. Nebulizers, also known as breathing machines, which is the prop that I have over there, turn liquid medication into a fine mist and allow people to inhale them through the mask. It soothes the airways and sends medication straight to the lungs, just like inhalers. Targeting the JAK-STAT pathway using these medications has also been proven to reduce symptoms. Some people with asthma also suffer its symptoms even during sleep. This is known as nocturnal asthma. While they're sleeping, these people have an increased risk for an asthma attack or can suddenly stop breathing for a moment during sleep. These effects mainly take place because of body positioning, which can make it hard for lungs to fully expand depending on how you lay down. Natural movement while sleeping, which can fluctuate cortisol levels, which are also known as levels of anti-inflammation for the body. Allergen exposure, including dust mites or pet hair dander, which can accumulate in your bedding and pillows and worsen symptoms, which is why if you have asthma, it's wise not to sleep in the same room as your pets. Before I close, I'd like to share some interesting facts. Asthma affects 1 in 12 people in the United States, which is around 8% of the US population. Nocturnal asthma can cause a sudden halt in breathing, like I said, but this can also contribute to memory loss because breathing is directly connected to emotional processing and memory recall. She is a key example of that. She stopped breathing quite a few times and she found that she kept forgetting a lot of simple stuff. She even forgot my birthday. But she found herself forgetting a lot of simple things as she stopped breathing. So after they found that out and she found treatment for it, she began regaining her memory. Surprisingly, asthma does not increase the risk of contracting COVID-19, which shocked me. Asthma doesn't just develop in childhood either. It can wait until adulthood to start affecting someone. Asthma is more common in boys than girls during childhood, but during adulthood, girls are more affected than boys. This is because testosterone is most likely believed to help with asthmatic symptoms. Swimming in indoor pools can help reduce asthma symptoms because the moisture in the air helps smooth the airways. And stress can also cause asthma symptoms to flare up. And these are my works cited, and that's my presentation.
Good.